Here, we explain how to solve the homework problem 109 in chapter 2. In this problem, we are given a cube made with platinum PT with edge length of 1.0 centimeters, and we want to calculate the number of platinum atoms in the cube, and also we need to calculate the radius of the platinum atoms, given the assumption that only 74% of the space inside this cube is taken up by the atoms, and all the atoms can be treated as a sphere. Okay, so right here as a sphere, a spherical in shape. Okay, let's look at the option 1, which is relatively easy to calculate. So since this is the cube, so we are given, so here's the cube, the length is 1.0 centimeter, so therefore the volume will be 1.0 centimeter to the power 3, give us 1.3 centimeter cubed. So therefore, for A, we want to calculate the mass of the cube. Then, because we know the mass of the single platinum atoms, then we divide the total mass of the cube by the mass of a single platinum atom. We'll calculate the number of platinum atoms in this cube. So therefore, we have the total mass of the cube is given by the volume of the cube times density of the cube. Then we divide it by the mass of a single platinum atoms. So the mass, the total mass of the cube, again, is a volume, which is 1.3 centimeter cubed, times the density, 21.45 gram per centimeter cubed. We divide this by a mass of a single platinum atom, 3.240 times 10 to the 22nd gram, and this gave us number of 6.620 times 10 to the 22nd atoms. Okay, that's the problem 1. Now in the problem 2, we know the total volume of the cube is 1 centimeter cubed, and 74% of this space are occupied by this many platinum atoms. And for each platinum atoms, the volume can be calculated based on its radius at this equation. Therefore, for B, we know that 1 centimeter cubed, that's the volume of the total of the cube. We know that 74% of this cube is actually occupied by how many atoms? We have this number of atoms. So therefore, 6.620 times 10 to the 22nd atoms times their volume, and the volume of all these atoms equal to 1 centimeter cubed with 74% is equal to the volume of this number of atoms. And we know that for each atom, platinum atom, the volume is given by this equation. So therefore, we can write that 4/3 times pi times r cubed. So therefore, we have that r cubed equal to 0.74 centimeter cubed over 6.620 times 10 to the 22nd times 3 over 4 pi. For r, it is 0.74 centimeter cubed, again 6.620 times 10 to the 22nd times 3 over 4 pi, and we take the cube root of this. This leading to r equal to 0.14 times 10 to the -7 centimeter. We convert it into picometer. So for each centimeter, we know it is 10 to the -2 meter, and we know that for each meter we have 10 to the 12 picometer. Therefore, finally, we have the radius of each platinum atom as 1.4 times 10 to the 2nd picometer.